Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is question number 2.13 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's check the question. What is the wavelength of light emitted when the electron in a hydrogen atom undergoes transition from an energy level with n is equal to 4 to an energy level with n is equal to 2. So friends, here we can draw a hydrogen atom and they are telling the electron is in the fourth energy level 1 2 3 and this is the fourth energy level. So our electron is there in the fourth energy level. It drops down to 2. So n is equal to 2. So n1 is our n1 is 4, n2 is 2. Now energy of the electron when it is in the n is equal to 4, we can say E2, and energy of the electron when electron comes to energy level 2, it is E1. So from here we can calculate del E, means the difference in the changing the energy level, that is minus E2 minus E1. So E2 minus E1 is the energy difference which is when electron is coming from N2 to N2. Now this minus sign in this formula shows the energy is emitted. So for this we have a formula del E is equal to RH, Rydberg constant, into Z square 1 upon N1 square minus 1 upon N2 square. So here RH is the Rydberg constant, Z is the atomic number of the atom for which we are talking about, N1 is the energy level where the electron was, and N2 is the energy level after transition where electron reaches. So now if we are putting the values, now RH Rydberg constant value is 2.18 into 10 to the power minus 18. Z value, Z here is hydrogen atomic mass is 1, so 1 square. Now 1 upon N1, our N1 in this case is 4 because an electron was present in the fourth level. So N1 we can say 4 square minus N2. N2 is the final state, that is in this case it reaches to the energy level 2. So we will write 2. Now start solving this. 2.18 into 10 to the power minus 18, and the unit will be joule because energy always counted in joule. Now into 1 upon 4,416 minus 1 upon 4. To solve this, 2.18 into 10 to the power minus 18, now it is 16, 1 minus 4. So we can write it 2.18 into 10 to the power minus 18 multiplied by minus 3 upon 16. Now if we do the multiplication minus 3 with 2.18, we will get the value minus 6.54 divided by 16 into 10 to the power minus 18 joule. Now do the division. We will get the value minus 0.408 into 10 to the power minus 18 joule. Or in the more appropriate sense, we can write shifting the decimal rightwards. So minus 4.08 we can write into 10 to the power minus 19. How? Shifting one step rightward means adding minus 1. So already minus 18 minus 1, it become minus 19 joule. So this is the value of the delta E, that is energy difference from N4 to N1 we counted. Now actually we have to find the wavelength of the light. So if energy we got from this, we can find the lambda. Let's see how. We knew E is equal to hc by lambda. We will use this formula. So from this formula we can say lambda is equal to hc by E. Now putting all the values, h is the Planck's constant, its value is 6.626 into 10 to the power minus 34 joule second. C is speed of light, value is 3 into 10 to the power 8 meter per second. Now E we calculated, its value is 4.08. Now here we are not putting the into 10 to the power 19 joule. Here we are not putting the minus sign. Why? Because as I told you earlier, minus sign here only shows the energy is emitted. This minus sign is not used in the numerical values. That's it. That's why we are not using this minus sign in the further calculation. Now second and per second cancel, joule and joule cancel. Now doing the multiplication 6.626 with 3, we will get the value 19.875 divided by 4.08, and taking all the powers together, 10 to the power minus 34 plus 8 and plus 19. Minus 19 from denominator goes in the numerator and changes its sign, plus 19. Now doing the division, we will get the value 4.86 into 10 to the power, now minus plus 19 plus 8, it becomes 27, that is plus 27. Now minus 34, so final answer will be minus 7, that will be minus 7 and meter. So lambda's value, wavelength, is 4.86 into 10 to the power minus 7 meter, and this is our answer of this question. So friends, calculation is very easy, only you need to remember the formula. So keep like, share and subscribing the channel. Till then, thank you.